Weather satellites and the instruments they carry are typically designed to last 3 to 7 years, but most work a lot longer than that. Earlier this month, a weather satellite that was revolutionary when it was launched in 1997 finally ran out of fuel, handing the baton to a new and more sophisticated observing platform. The retired satellite is called the Tropical Rainfall Measuring Mission, TRMM for short, usually pronounced TRIM, a joint venture between NASA and its Japanese counterpart. TRIM carried the first precipitation radar ever flown in space, returning data that allowed three-dimensional images of storm structure over much of the world's oceans for the first time. Yes, regular Doppler radars do this too, but they're land-based and can't observe beyond about 100 miles out into the ocean. TRIM took radar global, sort of. Its view was limited to just the tropics and subtropics between 35 degrees north and 35 south latitude, a zone where about 2/3 of the world's precipitation falls. In the U.S., 35 north reaches to about Los Angeles, Memphis, and Charlotte. When first launched in 1997, TRIM was simply intended to support research on global precipitation, to get a handle on average rainfall in parts of the world where such measurements were sparse. But before long, TRIM's data was being used almost in real time for detecting and monitoring flooding and to assess the rainfall potential of hurricanes and tropical storms before they hit land, as illustrated here with Hurricane Ike in 2008. TRIM had other limitations besides viewing only the tropics and subtropics. It could only measure rain that was falling at a pretty good clip, at least ½ an inch per day. Anything lighter wasn't detected very well. But TRIM's replacement can handle that and more. It's called the Global Precipitation Measurement Mission, or GPM, also a joint U.S.-Japan project. GPM can not only observe light rain, it can also differentiate between liquid water and ice, and thus it can also observe snow. That's important because GPM sees more of the Earth than TRIM did, from 65 degrees north all the way to 65 degrees south of the equator, basically from the Arctic to the Antarctic Circle, almost a global map of precipitation, and it can generate that picture in 3 hours. What's unique about GPM is that the satellite doesn't produce that nearly whole Earth view in such a short time all by itself. Instead, it combines and standardizes measurements from about a half dozen other satellites that have similar precipitation instruments, including ones from France, India, Japan, and the European Union. Thus, GPM is a great example of international cooperation, which, with few exceptions, is the norm in the atmospheric sciences. A whole new era of global radar coverage is about to begin. Paul Knight is back next with the extended forecast.